Hello friends. Last class I discussed about the introduction to encoder decoder and followed by the decoder, right? So encoder is one of the part of the this entire system, right? So in introduction section I have already discussed that. So encoder means that used to convert normally the normal decimal number to the coded number. And in case of the decoder, those coded number can be converted into the decimal number or readable number in case of the decoder, right? So decoder, how many types of the decoder and how can you design the decoder and what are this thing we have already discussed last few lectures, right? So now come to the encoder. So if you remember introduction to encoder and decoder, those who have not seen this thing, you can check my previous videos, the playlist digital electronics. So encoder is like this. Suppose 4 into 2 encoder and 2 into 4 decoder. This is encoder, this is decoder. So if I am giving the decimal number, that will convert it into the binary number here. Again in the decoder section, this binary number will be converted into the readable number, decimal number, right? So now here decoder I have already discussed. Now I will only discuss about the encoder. So basic encoder is the 4 into 2. That means 2 to the power n into n. So 2 to the power n is the number of inputs and n is the number of output. And that is the relationship between input and output in the encoder. So if you have the n input n output lines, you will have the 2 to the power n input lines, right? So here my n is 2, so 2 to the power 2, that is 4. Okay, so 4 is your number of input lines and 2 is the number of output lines, right? Now suppose if you want to send 0, okay, if you want to send 0 decimal number, and for 0 you should get the 0 0. So here I am, suppose this is input I0, I1, I2, I3. So I will send the logic 1 through the I0. Once I send the logic 1 through the I0, that means I am going to send the decimal number 0 through the entire channel, okay, input channel. So this so from the output you will get the 0 0 as a decimal number. Now if I am to send, if I am to send the 1, okay, and for 1 I should get the 0 1 at the output. So for getting 0 1 at the output, I have to send the logic 1 through the I1 channel, second channel. So what are the how the logic is going on. So for that, inside the encoder you have the decoder, you have the AND gates and OR gates that we can design by, if you know the truth table, we can easily understand how many components are there inside the encoder. Okay, so suppose I have total 4 number of input channels, right? Your output is suppose y1 or y0 and y1. Okay, so for getting 0 0, okay, so I have to send the logic. If I am sending the decimal 0 number, so for that I will get 0 0. So for that decimal 0 means I have to send the logic 1 through the I0 and other bit should be 0 0 0. Okay, so if I am to send the decimal number 1, okay, so I will get 0 1 here. So for that, which channel should be 1? This I1 channel should be 1 and other channel should be 0. In this way, if I want to send the 2, so for 2 means I2 should be 1, other channel should be 0. Okay, that is 1 0. And 1 1. 1 1 means I3. Okay, so if I have to send the 3, so I have to send the logic 1 through the I3 and other bit should be 0. Okay, so here you will get I1 1 1. So now if this is my truth table, so I can understand, I can write the logical expression from the truth table, right? So what is your y naught? My y naught is 1 1 for these two combinations, right? So that means it is you can two different way you can write the expression, right? So if you write, so for these two cases my y naught is 1 1, right? So it will be I naught prime, I1 prime, I2, I3 prime plus I0 prime, I1 prime, I2 prime and I3. Okay, right. So this is about the entire expression for y0. In same way you can write the expression for y1. My y1 is 1 1 for this combination and this combination. So, but in case of the encoder, you can see this is the complex expression, right? In case of the encoder, you can write as a, suppose you have the, in these two cases, you have the output 1, right? So, in these cases, which input channel is 1, I2 is 1. In this combination, which input channel is 1, I3. Okay. So, rather writing this one, I can write as a I2 plus I3. Y1 will be I1, my Y1 is I1, Y1 is 1 for this combination. So here it is, which one is 1? I1 is 1 and here I3 is 1. Okay. In this way you can get the idea about the 4 into 2 encoder. Okay, so if 4 into 2 encoder is there, you can directly write this expression. But if you have the higher number of the encoder, so you have to modify the expression like this way. Okay, I will come to this topic also. Now, so where we can use this encoder, right? So types of the encoder. First is the priority encoder. This I will discuss now. Priority encoder, decimal to BCD, octal to other number. Encoder means conversion between other number system to binary. Decoder means binary to other number system. So octal to binary, then hexadecimal to binary. Okay. So I will discuss priority encoder and octal to binary encoder. Decimal to BCD and the hexadecimal to binary. These two encoder are same as the octal to binary encoder. So these two topic I will discuss now. Okay. So in these cases, if you want to use the priority encoder, for that encoder you can use, if you want to convert decimal to BCD number, octal to binary number and hexadecimal to binary number, you need the encoder system. Okay. Now come to the priority encoder. So in case of the priority encoder, okay, so I'm writing the truth table first. So this is 4 into 2 priority encoder. 4 into 2 means in number of input lines are 4 and number of output lines are 2. Okay. So I'm writing first truth table. From the truth table I will get the idea about the structure. Okay. Expression. Now here. So first I'm writing. So if I'm giving logic 0 to throw the all input channel, so your output is XX. Okay, you should get any output. So that means now, so if we try to recall the 4 into 2 encoder, I am giving the logic 1 through the only one channel. Okay, so if you want to send the 0, so I am giving logic 1 through the I naught. If you want to send the if you want to send the decimal number 1, I am sending the logic 1 through the I1. Then in binary number system there are the lots of combinations. Okay, so if you send the different kinds of the combinations, suppose in combinations you have the multiple number of output, you have the one b number in binary number, in this binary number you have the multiple number of logic 1. So how we'll do this thing? Okay, so in previous truth table you have seen that, so in each cases I have the only one logic 1, but if you are sending the multiple number of logic 1 through the input channel, what will be your output? That is the priority encoder. Okay, suppose okay, suppose if I am sending logic 1 only through the I naught. Okay, so that means, so I naught is my highest priority, because here no channels are 1, so I am sending logic 1 through the I naught only. If you see the prefix, okay, if you see the subscripts, so I0 is the minimum subscript where I am sending the logic 1. Okay, so for that you will get 0 0. Okay, now I am sending logic 1 through the I1. Okay, and also I am sending logic 1 through the I naught. Okay, what will be the output here? Okay, so suppose here I am not sending. So what is the, if we see the number 1 is greater than 0, right? So if I am sending the logic 1 through the higher number of channel, higher order of channel, so we will not see, so how whatever information I am sending to the lower number of channel. Okay, you will not bother about this thing. Suppose if we will see, if I am sending logic 1 through the I1 and I2 I3 are 0, but for that, whatever input I am sending through the I0, either it is 0 or it is 1, I will not bother about this thing. If my I1 is 1, that means I will get 0 1 here. Okay, so suppose I0 is 0 and I1 is 1, I will get 0 1 here. Okay, now here, so I am sending 1 through the I2. Okay, so I2 is the maximum decimal number and here I3 is 0. So I3 is 0, it's fine. Okay, if we see the lower number, if whatever input I'm sending through the I0 and I1, if my I2 is 1, okay, if my I2 is whatever information I'm sending through the I0 and I1, because I0 and I1, 0 and 1 less than 2. Okay, so my output will be 1 0. So I2 is 1 means it's correspond to 2, 1 0. Okay, so it will be 1 1. If I am sending logic 1 through the I3, whatever inputs I am sending through the I0, I1, I2, so for all combinations I will get the 1 1 here, right? So now, so this is the truth table. Again I am repeating, suppose I am sending logic 1 through the I0 and higher order channels I1, I2, I3, these are 0. That means, so what will be the my binary output? It will be equivalent to 0 0 0. Okay, now if I am sending log, if you will see, so my I1 is logic 1, right? And so, and other two I2, I3 are 0. So whatever input I am sending through the I0, I will not bother about this one. So it is X, right? So I will get the 0 1, right? 1 is equivalent to 0 1. In this way I have written the truth table. Now, so this is the truth table. From truth table, if I get the truth table, I can write down the Boolean expression, right? So first here it is complex little bit. I am drawing the kernel. First I am drawing for Y naught. Okay. I3, I2 I am putting here, I1 and I0 I am putting here. Okay. Now my Y0 is 1 1 for this combination and this combination. Okay. So here you can see this is 0 1. Okay. I3 is 0 and 1. So this one, I3 is 0 and I2 is 1. I3 is 0, I2 is 0. So this is fixed, okay, and this is changing, okay. The I0 and I1 combination is access. That means access means it may be 0 0 0 1 1 1 1 0, okay. So it may be anything, right? 0 0 0 1 1 1 1 0. If two access means you can combine the four combinations 0 0 0 1 1 1 and 1 0, okay. So when my I3 I2 is 0 1, so 0 0 0 1 1 1 1 0. So I0 and I1 will be 0 0 0 1 1 1 and I1 1 0. This four combination should be possible for I0 and I1. Okay, that means in all cases my Y0 is 1. Okay, so here I am putting 1 in the entire vertical, in the entire horizontal row. So I3 and I2 is 0 1 and this is access. Access means it may be 0 0 0 1 1 1 1 0. Okay, now come to the here. Here you can see, here also my Y0 is 1. My Y0 is 1 means here my I3 is 1. Okay, my I3 is 1 for which cases? In these two cases my I3 is 1, right? So, and I0, I1, I2, this will be 0 0 0. 3 x-axis means it will be 0 0 0 0 0 1 0 1 0 1 1 0 like this way. Okay, so that means your I3 is 1 for these two horizontal row. In these two horizontal row, my I2 is either it is 1 or it is 0. Okay, either it is 1 or it is 0. And your I0, I1 is maybe 0 0 0 1 1 1 1 0. Okay, so in this entire 8 cell you will have the logic 1. I think it is clear. I3 is 1 for these two row. Now you can see I2, I1, I2 in any value. So in this corresponding cell you can see I2, I1, I0 values are different. Okay, so now if you want to do the pairing, so this will create a one octal and this will create a one octal. So what is your y0? Y0 is, from this octal you can write I2, and from this octal you can write I3. So this is your Y0. Okay. Now come to the Y1. Okay. In case of the Y1, in case of the Y1, you can see Y1 is 1 for these combinations and these combinations. Okay. Now I will input the values in the K-map. Okay. Now in this combination you can see my I2 and I3 is 0 0. Okay. I2 is I3 is 0 0 in this corresponding row. Okay. And what about my I1? I1 is 1. I1 is 1 for which cell? In these two cell my I1 is 1. Sorry. In these two cell my I1 is 1. See, in this entire 4 cell, my I2, I3 both are 0 0. Both are 0 0. Now, along with this, my I1 is 1. I1 is 1 for which two cell? These two cell, my I1 is 1 1. And now, I0 either it is 0 or it is 1. So, either it is 0 or it is 1. In this 4 cell, I have logic 1. Okay. Now, here, in this combination, for last combination also, my y1 is 1. Last combination it is same as the previous one. That means these 8 cells. Okay, 1 is for these two row, and this 3 value should be anything. This 3 value should be anything. Okay, so here this 8 cell can create one group, and these two and these two can create a one group. So what will be your y1? Y1 will be your I3. This will take this octal I3 and this quad. So for this quad, from here I2 prime will come, and from this two value I1 will come. Okay, right? So this is about the priority encoders. If you know the expression, you can draw the diagram, right? So now come to the octal to binary. Last topic, octal to binary. Okay. So this is octal to binary encoder. So octal means the base is 8, right? So how many distinct numbers are there? 0 to 7 distinct numbers are there, right? Total how many numbers are there? 8 numbers are there in case of the octal. Okay, so for that, so total input, so I am sending total 8 numbers to the encoder. I will get the corresponding binary number from corresponding octal number, right? So that means I am sending total 8 input numbers, right? So that means I have to send the logic 1 through the I0, I have to send the logic 1 through I1, I2, I3 up to I8. So total 8 number of input lines are there. Okay, so here I am writing Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So if you have the 8 input lines, okay, so it is the relationship between 2 to the power n into n. Okay, so your 2 to the power n is equal to 8. What will be the n? N is equal to 3, right? This is the relationship. If you know the number of input lines in encoder, you can calculate the number of output lines. Okay, so how many output lines are there? total 3. Okay, y0, y1, y2, right? So here, so if I want to send the 0, 0 means my I0 will be 1 and other bit should be 0, 0. This is 0, 0, 0. Okay, so if I want to send the 1 as octal number, so my I1 will be 1 and other bit should be 0. This will give 0, 0, 1 like this way. I'm writing all the thing. Okay, all other thing I'm writing here. Okay, right? So this is my truth table for octal to binary. So I'm sending, if I want to send the 0, 0, 1, 2, 3, 4, 5, 6, 7. If I want to get 0 from octal to binary, I will get 0, 0, 0. 0 means my I0 should be 1 and other bit should be 0, 0, 0. If I do the 7, so I'm sending the logic 1 through the I7 and other bit should be 0. From that I will get the I0 1, 1, 1 as a binary number, right? So this is the truth table. So if you want to write the expression, this is a complex expression. So if you recall the 4 into 2, when I discussed the 4 into 2 encoder, I told that you can minimize the expression in different way. You can modify the expression in different way. Okay. So how can you write? So first for y0, okay. For y0, I'm writing here. For y0, you can see y0 is 1 for last 4 and y0 is 1 for 4, 5, 6, 7. Okay, when my i4, i5 and i6 and i7 are 1, 1, 1, for this case my y0 is 1. Rather writing i0 prime, i1 prime, i2 prime, i3 prime, i4 and i5 prime, i6 prime, I can directly write as a only i4. Only I can consider the i4. Okay, so I4, I5, I6 and I7. What is my Y1? Okay, so my Y1 is 1 for these two and last two. So that means 2, 3 and 6, 7. You can see 2, 3 and 6, 7. So I2, I3, I6 and I7. Okay, now come to the last one, Y2. Okay, so y2 is alternatively 1. You can see alternatively it is 1. That means I1, I3, I5 and I7. If you see the alternatively it is 1. 1, 3, 5, 7. So this is my expression, logical expression for I0, I1, I2. Okay, now how we'll draw this logical expression? I'm drawing now. Okay, so you can see 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So the 0 bit lines is connected, all are connected to 5 volt voltage. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Right. So I'll take the connection from, for y0, I'll take the connection from 4, 5, 6, 7. 4, 5, 6, 7 and I'll do the OR gate. Here you will get y0. Okay, then for y1, 2, 2, 3, 6, 7. Okay, this is y1. Now y2 is 1, 3, 5 and 7. Okay, this is y2. Now when I'll give the 0, I should get the 0, 0, 0. So I'll check whether my diagram is feasible or not. Okay, so when I will send the 0, that means the 0 line will be connected with the 5 volt. Okay, Now, if 0 line is connected to the 5 volt and other lines are not connected with the 5 volt, okay, so that means, so other lines, the logic 0 will be sent through the other lines, right? So you can see here it is logic 0 is coming, here it is logic 0 is coming, here also logic 0 will come. So you will get 0 0 0 if I am sending. Now come to the suppose 7. Okay, so if I want to send the 7, if I want to send the 7, I have to connect this line with the 5 volt. Okay, the last line, because this is the 7 I am telling, I7. So this line I have to connect with the 5 volt. Now if we connect the 5 volt with the I7, you can see in all the expression I7 is there. Though the other bits, other channels are 0, okay, but I7 is connected with all these 3 OR gates. That means I am sending the logic 1 through the all 3 OR gates. If any input in the OR gate is 1, that means I will get output as a 1. Right? So as my I7 is connected with the all 3 OR gates, so my all the output will be 1 1 1. So that means when I am sending 7, I will get the 1 1 1. Okay, one more question I am doing, suppose 5. Okay, so I want to send the 5. The 5 should be connected with the 5 volt. Okay, so if 5 I am sending, what will be the output? You should get 1 0 1. Okay, you should get 1 0 1. Now you can see for getting y, so you should get 1 0 1 if I want to send the 5 volt. So that means this for y1 all the input will be 0, and for y2 and y1 any input will be 1. Okay, so you can see I5 is connected to 5 volt. So that means I am sending the logic 1 through the I5 and other bit should be 0. Now you can see I5 is present in y0 and y1. That means this I5 is 1 also, this I5 is 1, and others are 0 0 0. If you see the y1, in y1 I5 is not there, so all the bits are 0 0 0. So if all the bits are 0 0, if you do the operation, I1 will be 0, but in case of the y0 and y2, my I5 is 1, right? So though the other bits are 0, but my I5 is 1. That means if any input of the OR gate is 1, then I will get output as a 1. So I will get y0 and y2 as a 1. Okay, so if you do the connection like this way, you will get the total octal to binary encoder. So this is about my encoder. So next class I will start with the sequential circuit, flip-flop and latch. Thank you, and please like, share and subscribe my channel.